Okay, so let's start. Okay, so last time I told you there are two ideas to connect two computers together. Okay, one idea we call it circuit switching, and the idea in circuit switching is, and this is the idea used in telephone when you inside telephone network. So the idea here is that when you as you see here, when you dial a number, so actually the network itself is going to create a dedicated path or dedicated cable between the source and the destination. So this is a main point here. Your reserve resources. The key here is like resources. So you have dedicated resources. Okay, that's what we do in circuit switching, and this may be okay for voice communication. Why? In case of voice communication, you wanna transmit voice all the time. Okay, so it may be okay. So that means I'm gonna use this cable all the time. Also, you have to keep in mind this cable is not shared. This is yours. You do reservation. Before you call, you need to reserve. You do reservation. This is circuit switching. Yes. No, this has nothing to do with the internet. This is the landline phones. It's not the internet. The other one is the internet. You got what I'm saying? The other one, we call it packet switching. That's what we use in the internet. TCP is used in the internet. Is that okay? So this one is used in telephone network. The other one, we call it packet switching. So the idea of the packet switching, as I told you, is if you want to transmit data, that's what we do in the internet. Number one, there is no reservation. You don't need to reserve. You don't need to ask for a permission. You don't need to create a connection. Is that okay? Just if you want to transmit, just transmit. Transmit your packets. Okay? Do I promise anything? Here, anything you transmit is going to get delivered. Why? Because you have resources. There is a cable. You got what I'm saying? But in the internet, you don't have anything. Okay, so if you that's why you may transmit some packets and these packets are not delivered. Okay, because there are no resources. Okay, so that's what we do in the internet. So I'm going to give you more details, but I want you to understand that circuit switching is good for voice communication. Packet switching is good in data communication. Okay, why? Because what we do in the why this one is bad in data communication? Simply because if we use the internet here for data communication, we are not going to send the data all the time. If you are going to send data all the time, so this one is better. You are not going to send the data all the time. Okay, you have connection, but for example here, I'm not sending anything. Now I'm going to send an email. Now I'm going to run nothing, and then I'm going to have some other activities and so on. Okay. And then also here, I explain the idea of multiplexing and demultiplexing, okay? So you can tell from the name here, multiplexing means if you have one medium here, like you have this cable has like very high speed, okay? So what we can do, I can collect the data from different computers, and then I can, after I collect this data, I can transmit all of this in the cable here, and then I can split them back here. Okay. So for example, if this computer want to communicate with this computer, so I'm gonna put all the data together, send all the data here, and then I'm gonna split it here. Okay. Again, why I need to do that? Because actually, this is how can you for efficient use of high speed link. because this link is very high speed. I'm not going to give it only to one computer. Okay, so I'm going to collect the data from different computers. When you collect the data from different computers, that's what we call it multiplexing. Okay, when you split the data again, that's what we call demultiplexing. And so now what I want to say here is we have resources, which is this cable, and we want to share. These resources. And also I told you there are two ideas to do that, okay? Either by frequency division or time multiplexing, okay? So what is the difference between them? The difference is that here, let's start, for example, with the time multiplexing. The time multiplexing means this is all the frequencies we have, the bandwidth, all the frequencies we have here in the cable. So what can we do here is that you can take all the frequencies, but not all the time. So here, one user you can take the full bandwidth, but as you see here, just in time slots. So these are for the same user. Is that okay? Or, so that's what we call time multiplexing. You can tell from the name, you actually, we split the time, okay? So you have your own time slot, you have your own time slot, you have your own time slot, and in every time slot, you use all the frequencies. Is that okay? So again, as you will understand better in this course, the more frequencies you have, the higher speed you can transmit, okay? The other idea is that frequency multiplexing, okay? So this is the whole bandwidth of the cable. So what I'm gonna do, I'm gonna give you just some bandwidth, small bandwidth. So and in this case, you can transmit all the time, but using your own frequency, okay? So for sure, so here you have very high speed for sure, but not all the time, okay? Here you have a small speed, but all the time. You understand what I'm saying? So that's how we can share the cable. And this idea, we call it actually static multiplexing. The idea of static multiplexing, this kind of multiplexing. In the internet, we do also multiplexing, but we don't call it static. It's not static. We call it statistical. Statistical, where just if you want to transmit, you just transmit. And the idea here, as I told you, is that if you have, and also as you're gonna understand later, the idea is that if no one, go back, okay. Static. Yeah, so in the internet we use statistic. We call it statistical. Okay, here this one is static. You can tell from the English name. Static means fixed. Okay, because you have fixed frequency, fixed bandwidth. Okay, the other one is statistical means it may be at a certain point you are going to take too much frequency because no one is using the resources. You got what I'm saying? I'm sending the routers are not busy. Okay, I sent packets. And I'm going to take too much resource. In another time, I'm going to take only a very small speed. You got what I'm saying? So it depends on the situation of the network. That's why we call it, it's not static, it's not fixed. Here you have fixed resources, other one you don't, okay? Anyway, so that's it. Again, just here, I want to show the multiplexing. As you see here, we have user 1, user 2, user 3. In a certain time, as you see here, I'm going to take data from here, data from here, data from here, and that's what we send through the cable. Okay. Again, the main problem with static multiplexing. Again, this is a problem if you use it for data, but if I use it for voice, it should be okay. The main problem here, because we don't share resources. Very important to understand the word share. Because that's what we do in the internet. In the internet, we share resources, okay? Here we don't share resources. You have your own cable. You have your own bandwidth. If you don't use it, no one else will use it, okay? So what happens here, as you see here, here this user has his own bandwidth, but it's not used. So, and no one else will use it. So that's why we are gonna lose this bandwidth. No one is using it, okay? So this is a capacity and no one is using it, okay? Because you have dedicated resources. This is, again, this idea is completely different from the internet, okay? This is good for voice because at least we have guaranteed performance. The performance is guaranteed. So that's why you should notice if you call someone over the phone, maybe because these days the landline phones are not very popular, but in the past they were very popular. You can see that the performance, the quality of the voice in the landline phones are much better in the quality of the internet. But again, I understand now that the quality voice over being now the quality became too good. But the main reason for something like that is here you have guaranteed performance. The internet you don't have. Okay, so that's why sometimes the voice can be broken, you may lose connection. In the landline phones, this doesn't happen because there is a keyboard anyway. Okay. Yes, it depends on how you, because in different countries you may use different technology. You got what I'm saying? So in the middle, but again, there are two different of ideas. If you some communication, some cheap communication can be done over IP. Okay. Other communication can be done using cables. You got what I'm saying? But yeah, so if it is between different countries, there may be different technologies used in the middle. You still, even for the other one, even if you have routers, still you need to connect the routers together. You got what I'm saying? I don't want to say it's which one is more expensive than the other. I can say this is somehow an old technology, or we have two different ideas. We started with this one in the before we have the current internet we have. So we started with this one, okay, and even this one also can help you to understand the packet switching in the internet. You got what I'm saying? Because in case of packet switching, you don't do any reservations. That's why the performance is not guaranteed. Okay. The second one, as I told you, packet switching, and that's what we use in the internet here. We divide the message into small pieces, we call it packets, and then you can transmit these packets. This packet can be reassembled, as I explained last time. It can be reordered. There's a sequence numbers, and you can reorder them. You may lose some packets in the middle, okay? And this is something you need to handle. Again, because there is no agreement between the sender and the network. You're not going to ask for a permission. Congestion can happen, and I explained last time or before I explained what I mean by congestion. Congestion simply means if you have a router and this router receives everybody is transmitting at the same time. You got what I'm saying? So in this case, this router is not going to be able to process all these packets, okay? And then it may drop these packets. You got what I'm saying? So that's what we call congestion. So this is something we need to handle. By the way, before I continue, there are three important things we need to handle. The first thing, let me write them here because we are going to teach some of them in this course. Okay. So we have here what we have a problem, we call it congestion, as I told you. So we need a mechanism for congestion control to solve the problem. Also, we have some kind of errors, so we need error control. Okay. Also, we have something we call flow control. I want you to understand what are the difference between these are three problems, and the protocols we use in the internet should fix these problems. Okay, I told you what I mean by congestion control before. You have a router. This router is connected. Many computers are transmit data at the same time. Okay, more than what the router can output. For example, if just an example, if the router can process 3 packets per second, just any numbers, and the total here, for example, is 5 packets per second. What I'm saying? Again, because if you want to transmit, just to transmit. So what is going to happen is that I'm going to store these packets here in the queue, And once the queue is full, I'm gonna start to dropping the packets. Nothing else I can do. Okay, if this situation continues. This problem is handled by the transport layer. So there is some mechanism to do that. Okay, so for sure this will be out of the scope of this course, but this problem is handled by the transport layer. The other one here, we call it error control. Okay, in case of error control, as I told you, for example, I have a message. As an example, for example, I have a message. This message, I'm going to divide it into, for example, 3 packets. This is packet number 1, packet number 2, packet number 3. I transmit them, but the destination is going to receive only 1 and 3. So 2 is missing. You got what I'm saying? Or maybe this is because we have actually 2 types for these two. We have 2 types of them: hub by hub or end to end. So end to end means from the source to the destination. Hub to hub, because we have a computer here, we have a router here. We have sorry. Okay. So we have here router, for example, router, and then we have the other computer. So these 2 problems can be handled end to end, okay? Or also we are these 2 problems, okay? We can also have these 2 problems hub to hub. You understand what I mean by hub? Hub, link to link, okay? So we can handle it here, we handle here, also we can handle it here. It's the same problems, okay? So very important to understand when I say hub by hub, so that means it's a second layer, because the second layer should take care of hub communication. So that means these 2 we have mechanisms for error control and flow control in the second layer, and that's what I'm going to teach for sure in this course. We are going to teach the second layer. Okay, end to end, this is a transport layer. If you want to control it end to end, okay. So error control, guys, means one example. For example, as I told you here, I transmit packets 1 to 3, but actually 1 of them was missing. So there should be some mechanism to ask. The easy way, I can ask the source, please retransmit packet number 2 because I didn't receive it. Okay. Same thing can happen hub by hub. Okay. So so it's not also error doesn't only mean you are losing some packets, but maybe the packet you sent to me is corrupted. You got what I'm saying? So 0 is converted to 1, or 1 is because of distortion. Okay, so there may be an error in the packet. Anyway, so this is what we call error control. Another thing we call it flow control. Okay. Anyone here has idea about what's the meaning of flow control and how it is different from congestion control?
How much data they will send in a certain the amount of data that will be sent.
Okay. You're very close. Okay. So here's the idea is that we have 2 computers. Either again, it can be hub by hub, or it can be end to end. It's the same thing. We have a computer. One computer is actually generating data, and the other one is absorbing data. You got what I'm saying? Okay. So here we have one computer. This computer is generating data. This computer is processing the data or absorbing the data. Okay, we have to be synchronized. I cannot be two-phase, transmit data, and then you don't have enough CPU, you don't have enough RAM to process this data. We have to be synchronized. You understand what I'm saying? That's what we call flow control. So and again, flow control can be hub by hub, or it can be end to end. It can be end to end. For sure, this is completely different from congestion. Both of them is about speed, okay? But congestion is actually completely different. Congestion means this is a router receiving data from different computers with a very high or with very high rate, more than what I can process. Okay. But flow control, that means if this computer cannot overwhelm me, okay, so there should be some way so that we can synchronize somehow, or we, if you transmit too much data and I'm not able to process them, there should be some way to control this speed. You got what I'm saying? Anyway, so in this course, because I'm going to teach the second layer, you will see error control, you will see flow control, but again, it's going to be hub by hub. Okay, but still we have also error control and flow control, but end to end. Okay. Anyway. No, you can fix it. This is a very good question. It depends on the protocol. In some protocols, I don't care. I don't like, for example, I'm going to explain shortly. I'm going to explain TCP and UDP. Okay, so these are mechanisms. In some protocol, you may not have them because I don't need them. For example, as I'm going to explain, we have in the transport layer, we have TCP and we have UDP, okay? In TCP, we have error control, we have congestion control. UDP, it doesn't have neither. It doesn't have congestion control, doesn't have error control, doesn't have anything. Very simple protocol. It doesn't mean it's bad, but it has its own applications, as I'm going to explain later. You know what I'm saying? Yeah, no, that's okay. I welcome any questions.
So it's more of the device and the middle device, right? And
What's that?
there's, you mentioned that the flow control that the flow control is more of between end-to-end devices, and the conjunction is between end devices and middle devices.
No, wait. I said what I said. Error control or.
No, I'm talking about conjunction and flow control.
Okay, flow control first, it can be end to end. Okay, this computer is overwhelming this computer with data. I'm not able, I don't have enough CPU, enough memory to process this data, or it can be hub by hub. So this computer is overwhelming this one, or this one is overwhelming this one, or this one is overwhelming this one. Yeah. Right. What I'm saying. So this is for flow control. Congestion control, a router is receiving data from different sources, and I have to forward them, okay, from different computers. It's not about computer is overwhelming another computer. It's about too much data, and I'm not able to process all of them. You can think this way. Yeah, many different computers transmit too much data to the router. I'm not able to process all this one. But here, it's about, yeah, computers communicate. You cannot think about it. One computer is generating data, another computer is processing the data, okay? So we have to be synchronized. You cannot just give it to me and I don't have enough CPU RAM to process them. You got what I'm saying? We need to synchronize. That's what we say. Anyway, I'm going to teach you flow control in the second layer, but you should understand we have flow control. We don't have congestion control in the second layer, okay? We have, we do it in the transport layer, but in the second layer, we are gonna have error control and flow control. Yeah, sure. What is that? Which control? Hub-to-hub control? What do you mean by hub-to-hub control? Hub-to-hub means, okay, maybe I need to, so we have a computer, okay, and then we have several routers in the middle, and then we have another computer. We should understand two things. When I say end-to-end, you can tell from the English name, end-to-end, okay? End-to-end means from here to here. I don't care about the middle. That's what we call end-to-end. Is that okay? This is one thing. The other thing, when I say hub by hub, okay? You know, in English hub, when you hub, okay? So hub to hub, this is one hub, another hub, and so on. Okay? So when I say hub by hub, that means it's here, 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 and so on. Got what I'm saying? Yeah. So I'm going to use these two terms, end-to-end or hub by hub. Hub, yeah, for sure, because this is the responsibility. You mean hub by hub is the second layer. This is the responsibility of the data link layer is just to connect from one computer to another computer. This is the second layer. Okay. Is that clear now, or still you have I answered your question? Okay. So as I told you before, you transmit the packet. These packets, maybe this packet is gonna take different routes. We need to reorder, we need to reassemble them at the destination. We may lose them, as I told you. Very important, as I said, there is no resource reservation, and that's what we call statistical multiplexing. Okay, so statistical means the bandwidth is used on need or as needed. I'm not gonna reserve bandwidth for you. No, all of us. We share certain bandwidth. Maybe at this moment you are getting too much bandwidth. Okay, in in another time you don't use any bandwidth. Someone else is using it. You got what I'm saying? So that's why we call it statistical. Okay, so for example, also to understand it better, for example, we have this cable, and this cable is actually 6 megabit per second. This is the limit of this cable, 6 megabit per second. I'm gonna do something very weird here. Look what I'm gonna do. I'm gonna give this computer 4 megabit per second. I'm gonna give this computer 4 megabit per second. The total is 8, which is more than what I have. You are spending more than what you have. Yes, we do that. Why? What is the logic? The logic is you are not gonna use this 4 all the time. You are not gonna use this 4 all the time. You got what I'm saying? You are not going to use it all the time. If you are going to use it all the time, well, the network will be in trouble. We will be in trouble because you are going to exceed this one all the time. So, but in reality, because this is data communication, it's not a voice communication. Data communication, that means you are not going to keep sending all the time like voice. Okay. Anyway, so for example, if you see here, this is the bandwidth for A, this is the bandwidth for B, just as an example. If I add them together, this is the total bandwidth, and this is my limit. The limit is 6. Okay, so what happens here? Maybe at sometimes we are gonna exceed. What we can do here, we are gonna buffer these packets at this moment. We are gonna buffer them, and then if this situation continues, so we are gonna start to dropping them. I'm gonna drop, because you have to keep in mind the network does not have infinite resources. We have limited resources, okay? I have limited RAM, I have limited CPUs, okay, speed, okay? So once the RAM is full, so I'm gonna start dropping packets. Nothing else I can do, okay? It's a problem, but we can handle this problem by the protocols, okay? Yes, this is congestion control. Yes, so because this router, this is router, you have data coming here, okay? But again, the thing is that if this situation, if for a short period of time, I can handle it because I can put it in the buffer. Yes, I'm going to create a delay because I have to put it in the buffer, and then I'm going to take it from the buffer. But if this situation continues for some time, for sure it's not good, because we need to fix it. Otherwise, we're gonna start dropping packets. If this is a short period of time, we may not need to drop packets. But just I'm gonna create a delay, but I'm not gonna drop packets. Okay. The other thing here to understand, it's also very important. Okay, I want to tell you something important, guys. How I'm gonna ask you questions here in this chapter. In this chapter, I don't want you to memorize anything, so just don't memorize. I just want you to understand it, and then you can use your own words to answer questions. Is that okay? So, for example, I also have some numerical example to better understand the difference between circuit switching and packet switching. For example, if I have this cable, and this cable is 1 megabit per second, and we have in users that are using this cable. So, for example, in case of circuit switching, I can support only 10 users if I give every user 100 kbit per second. So every user 100 kbit per second. If you multiply it by 10, so I'm gonna so So here, this is the resources we have. I'm going to split it, okay? Because everybody's going to take some. So I can't, in case of circuit switch, I can't support more than 10 users. Is that okay? However, if you use packet switching, if I support 35 users, assuming every user is going to be active only 10% of the time, because if this is data transmission. You understand what I'm saying? So you're not going to transmit all the time. We're assuming you are going to only transmit data only 10% of the time. If okay, and this is very reasonable in case of data transmission. If this is the case, if I use this one, it's waste of resources. Waste of resources. Why I give you a bandwidth and then you are going to use only 10% of the time? You got what I'm saying? Doesn't make any sense for data. But if I give it for 35 users, so in this case, it may happen that the total transmission is more than 1 megabit per second. It may happen at some times, but the probability, okay, you don't need to know how it is calculated, but I just want you to understand the difference between these two. So here, given everybody's going to use it only 10% of the time, the probability that I have more than 10 computers active at the same time is just 0.0004, almost nothing. You got what I'm saying? So if I support 35% of the users, everybody is going to use only 10% of the time, the probability to have a problem, the probability that 10 probably means more than 10 are sending at the same time, okay? It's just 0.0004, almost nothing, okay? Anyway, any questions? Okay, so just in one sentence, the difference is that circuit switching means two words: reserve resources. You reserve, everybody has guaranteed resources, okay? Which is good for quality because you have your own resources. In packet switching, you can use bandwidth on demand, okay, as you need. Okay, for sure, if I can't, I'm gonna drop your packets. I don't care. Okay, anyway. Yeah, again, so here I want to tell you in static multiplexing, if you don't use your bandwidth, we're gonna lose it. You are gonna lose it, okay? So at this time slots, we're gonna send anything. However, in case of static multiplexing, we can. It's better for utilization of the resources because we can use it. Because if you don't transmit, so I'm going to take the packets from other users. That's what I want to say. This is the difference between static and, again, guys, I don't want to understand that I'm saying static multiplexing is or packet switching is better than circuit switching. I'm not saying that, okay? I'm saying for voice communication, maybe circuit switching is better, but here we are talking about data communication. In data communication, you're not going to transmit all the time, okay? If you transmit all the time, it's going to be big trouble for the internet because all of them are going to be congested because here I have more users and more resources. So, but again, the assumption is not all of them are going to use it at the same time. Okay, guys? Any questions?
For the packet switching and stuff?
Yes. Yeah. Okay. Yeah. Static key means you have your fixed resources. Statistical means on demand. Okay.
Example is the circuit switch.
Yeah. The multiplexing we use in circuit switching, we call it static multiplexing. Okay. The multiplexing we use in packet switching, we call it statistical multiplexing. Great. So now I want to, in 3 slides here, I want to answer a question. I told you before what we do is that if we have a message, big message, and usually that's what this is a situation, we're going to cut the message into segments or pieces or chunks, whatever you want to call it. And every piece I'm going to put in a small bucket and to transmit. So I'm curious to know why we do this way. Why it's not message instead of packet switching? What we do, we send the packets, and the size of the packet is much smaller than the message because we cut the message. So I just want to tell you, so why we don't have message switching? Why packet switching is better than message switching? You understand what I'm saying? Why we cut it into pieces? Why we just, instead of making this one, I can make only one packet. I'm gonna put the complete message here, and then the route, some information here, and that's it. No, we don't do that. We cut it into smaller pieces. Actually, I'm gonna give you some numbers. I'm gonna give you details to understand why. But conclusion, two reasons, okay? The first reason is actually, if it's gonna be a longer delay, if you transmit a message, a big message, the delay is gonna be too long. Why? I'm gonna tell you why, okay? This one thing. Also, the error. The second motivation is actually the error is gonna be high. The error in the transmission is gonna be too high. Okay, so now I'm gonna give you conclusion to understand it. Okay, let's start with the first one to better understand the main point here. So what I'm saying here, for example, if I have this message 7.5 megabits per if you have 7.5 megabits, if this is the message, assuming here the bit rate of the link, bit rate again. So this link, the bit rate means how many bits you can transmit per second, speed, okay? And we're gonna come, well, I'm gonna explain this one also later to know, as I said before, every cable has a bit rate, okay? I cannot transmit 1 trillion bits per second. There is a limit, okay? And later you'll understand why, okay? But anyway, if this is so what happens here, if I wanna calculate the delay, so it's gonna be M, the message, divided by the bit rate, which is R. So here, and then I'm gonna multiply by 3 because we have 3 connection here. So I'm gonna transmit a message here, and then this message has to go here, this message has to be here. So I'm gonna, this is the time, M, the size of the message divided by the bit rate, okay? This is gonna give you how much time it's gonna take to transfer one hop, how much time for one hop, and then I'm gonna multiply it by 3. So if I do this way, if I transmit here a complete message with 7.5 megabits, so this total, I'm gonna finish in 15 seconds. Okay, but if I cut it into small pieces and to transmit them, okay, it may take here only 5 seconds. Given this number, forget the numbers, okay? I'm just putting some numbers so don't look at the exact number 5 and 15. No, just to try to see it how I reduced it from 15 to 5. Why? Because I'm going to tell you what is the main point here. The main point is, okay, there is something very interesting here we did. We call it here, we split the message, just any number. I'm assuming it's 5,000 packets. We have 5,000 packets. So when I transmit packets, I'm going to create something like pipeline. Have you ever heard the word pipeline? We use it in too many things, computer organization and other things. Anybody can describe what is the meaning of pipeline? In just a few words, what is pipeline? What is that? No, I'm asking about pipeline as opposed to anything in manufacture, in computer organizations, the idea of pipeline, what pipeline is.
Handle many processes at the same time.
Yeah, all of us can work at the same time. You don't need to wait me until I finish to start to work. All of us can work at the same time. This is the meaning of the concept in any field. Okay, it's the same thing here, because what happens here is that these computers are not gonna work until we finish the transmission of the packet from here to here, and this one takes so only one transmission is active at a time, and then you have to wait until to transmit this one from here to here. We have to wait until we transmit this one from here to here. Is that okay? However, here what happens, if you look how we created a pipeline here, and you may understand better what I mean by pipeline. So here there's one packet, one. So I'm gonna transmit it to here. Is that okay? And then now we transmit it to here, and this one also working. All of us are gonna work right now all the time. So now what? So these two are working at the same time. And now here you are transmitting 3, transmitting 2, transmitting 1. At this time here, the pipeline is full. So it's a very beginning, we need some time to fill the pipeline. Okay. So here only one transmission is active here. Okay, now it's 2, now it's 3. Now the pipeline is full. Once the pipeline is full, you can see all of them are transmitting at the same time. So here you transmit 4, you transmit 3, you transmit 2, you transmit 1. So if you look what we had here, we have transmission all the time. So if you see here, guys, here we fill the pipeline. Here we empty the pipeline here. Okay. Anyway, so if we do this way, we can transmit message faster. So this is one motivation why message switching is not good. Why packet switching is better than message switching. This is one reason. Is that okay? Any questions? Okay. The other thing is the error rate. For example, here, if the bit error rate here 10 to the power of -6, I told you what this one means before. This is a probability of having an error, or in other words, every time I transmit 10 to the power 6, we're gonna have one bit error. 10 to the power 6 bits. That's the meaning of it. Okay, so every time, for sure, the lower the number is going to be much better. Okay, so this is what we call bit error rate. One, it's like any probability. One, again, forget the calculation. I'm going to show you how I calculated it, but I just want you to learn that here, if you send, this is the conclusion here. If you send a big message, the probability of having error is going to be higher. And then you have to retransmit the whole message again. You got what I'm saying? But if you transmit small packets, so the error is going to be less. That's what you are going to see right now. So this is the probability of having an error. Okay, 1 minus this probability is going to give you the probability of transmitting a bit successfully. 1 minus it. Okay, so now I'm going to show you 2 cases. In one case, I'm going to transmit 1 megabit. Okay, so in another case, I'm going to transmit 100 kilobits in case of small size. Okay, in case of packets. So if you see here the probability here, so this is the probability is going to be 1/3. It's very high. So the probability to get the message delivered successfully is 1/3. Here is going to be 0.9. You got what I'm saying? So that means I need to, in case of corrupted message, I need to retransmit. So here, although this one is just 1 megabit, maybe I'm gonna need to transmit three transmission per hop. In total, maybe I need to make 6 megabits retransmission in order to get it delivered here. Is that okay? Because we have 2 hops here. Okay. Anyway, but if you look at, because this probability is too high, so maybe I'm going to reduce the number of transmission to retransmission, because I need to retransmit to fix the problem. Is going to be only 1.1. Anyway, so the conclusion is, and even makes more sense. So if you have like a big message, if you have 1 error, you are going to retransmit everything. You got that sense? So that's why. Anyway, so conclusion, I don't want to spend more time on this one. I just want you, the purpose of these 2 slides, to justify why we don't use message switching, but we use packet switching. And the difference between packet and message, the packet is the size of the data in one packet is much smaller than the size of the data in a message. It's the whole message. Why we cut it into pieces, and then I just give you 2 justifications here. Number 1, it's going to take less time because of creating something like pipeline. Number 2, it's going to create more error. We're gonna have more error here. Okay. Anyway, I just here in this picture. To calculate this. No. What I'm saying, if I want to ask here, I'm gonna ask you justify. For example, all what you need to know here, why in the internet we don't have message, we use packet switching instead of message switching. That's what, okay. The answer should be because of the delay, and also because of higher transmission rate, okay, or higher success rate in the transmission. That's it. Okay. Anyway, so I just in this picture, I want to choose, as I mentioned, in circuit switching, before you transmit, you need to dial a number. When you dial a number, actually, you are gonna establish a circuit. So there may be some delay in the beginning to establish a circuit, and then after we establish a circuit, when you hang up, we need to release. We need to terminate the circuit. We need to release the resources so that I can use it for someone else. You got what I'm saying? After you are done. But here, in case of packet switching, you just send packets this way. Any questions? Great. So the last part here in this chapter is about communication layer, communication network layer. Let's take the attendance here. Okay, so you are ready. Just be ready. I'm gonna give you the code now. Okay? Seven, 3, 8, 7. 7, 3, 8, 7. Okay. Hagar. Okay. Okay. Because it's not in the last time, in the first time. Have you attended the first time? Because okay. Because it's not shown. It's shown like unknown. It's not shown as attended or absent. You got what I'm saying? Okay. Thanks. So 7, 3, it's okay. So let's continue to the last part in this section, guys. So can you close the door, please? So can you close the door? Yeah. Still, we have 2 minutes. Yeah, you have to know when you come here. If you have, I'm gonna continue until 8:50. This is my system, okay? Yeah. I remember in the United States, some students complain about this one in the evaluation, but looks like a good complaint. Yeah, it's not a bad complaint. Okay. So when a student said, when we go to Dr. Mahmoud's class, we know that we're not going to leave early at all. Anyway, that's how it is. Okay. Anyway, so what I'm saying here, guys, you know the idea of layers. I just want to make a very quick revision about layers. You know, in the internet, or sorry, in the network, we have the idea of layers. So we have here layer number 1, physical. We have layer number 2, data link, network layer, transport layer, session, presentation, application layer. And in TCP/IP, we actually merged these 2 layers together. We called it host to network layer. It's the same thing here. Network, we called it internet, transport to transport. And these two layers are not there anymore. However, if you need any service here that was provided here, you have to put in the application. And as you know, in this course, we are gonna focus on in the first 3 chapters, we are gonna be here in the first layer. And then I think there are 2 chapters here. and one chapter here. Okay, so only in this course we're gonna focus on these three layers. Is that okay? So first of all, you should understand what you mean by layer. What layer means? Okay, if I wanna define it, layer means phases. Phase number 1, phase number 2, phase number 3, phases. Okay. And I have a very good slide here. Even in our life, in many things, our life, we do it in phases. For example, if you want to transmit a letter, you have to write a letter, you have to put it in an envelope, and then you have to drop it in the mailing box. Is that okay? So this is a phase. And then after that, the letter is carried by the post office from your home mailing box to the office. This is another phase. The third one, the letter is delivered from this office to the other office at the receiver. Okay, and then you can see like we have phases here, and everything we do here, we're gonna do the opposite here. Okay, so for example, here you put the letter in envelope, we're gonna remove it from the envelope. Anyway, so it's almost the same thing here. We have different layers. More importantly, just I'm gonna take 1 minute here. Yeah, I know. I'm doing a revision in this chapter, so maybe I will finish it in next week. I know. Okay. So the idea here, first of all, I put why we do it in layers this way. What is the purpose of it? Why it's not only one thing? Why we make it into phases? Okay, there are several reasons here. I can quickly say, just give me just 1 more minute, only 1 more. Okay. So if you have a big task, if you have because networking is something or data transmission is something very complex. Okay, so usually if you have a big task, what we do, you split into small tasks. You got what I'm saying? Or subtasks. It's exactly the same thing. Okay, I can simplify the network design, implementation, and testing by split. Instead of doing very big thing at once, no, it's going to be like you have a protocol to do something, and then another protocol, so you can cut it into small tasks. Every protocol is going to take care of one thing. Okay, so you can simplify how network protocols are designed, because every protocol is going to take care of small task. It's going to be like flexible. Not only that, if you change one layer protocol, is going to be transparent to the other protocols. For example, here, if the physical layer is using wireless communication or wired communication with optical fiber, I don't care. All what I'm expecting from the physical layer, okay, for the data link layer, when I transmit something to the physical is going to get it delivered. Okay, I don't care what you are using. Anyway, we are going to continue last time. So we should finish this chapter by next time, and we should start chapter 2.
Thank you, ma'am.
Thanks.